Welcome. This video is going to take a look at a few more of the problems from Section 3 of Chapter 1 in the Brown SL Chemistry book. Starting with number 57, which asks, which has the greater density at STP, hydrogen or helium? Well, a few things you have to put together on this one. First of all, hydrogen is H2, whereas helium is just He because it's a noble gas. And density is your mass over volume. Now, since it's at STP, we're going to be looking at 2.02 grams of hydrogen in 22.7 liters versus 4.00, I believe it is, 4.00 grams in 22.7 liters. So when you compare this, you're taking the smaller number by a big number, slightly bigger number by the small number, and you should be able to deduce that since hydrogen has less mass in the same volume, it's going to be less dense, and helium, on the other hand, with more mass in the same volume, will be the more dense gas. Number 58 asks you to figure out the amount of oxygen produced at STP if you completely combust 125 grams of octane. So first thing is to get the balanced equation, and I've written in the amounts that we're dealing with here. So I could see that I could change my 125 grams to moles. So 1 mole of octane I have at 114.26 grams per mole. So if I take 125 and divide by that, I get 1.094 moles of octane. But octane and oxygen occur in a 25:2 ratio, or 12.5 to 1. So now if I multiply that by 12.5, I've actually got 13.67 moles of oxygen, and because it's at STP, I know there's 22.7 liters per mole, which gives me a volume of 310.4 decimeters cubed. So 59, they give you kind of an odd collection of information. Again, it's kind of like, what am I supposed to do with this? So let's take a look at what they gave you. First of all, they tell you you have an unknown sample with a mass of 3.620 grams, occupying a volume of 1,120 centimeters cubed at a pressure of 99 kilopascals and a temperature of 25 degrees, or 298 Kelvin. And we also know that 2.172 grams is oxygen and 1.448 grams is sulfur. And they want to know the empirical and molecular formulas. Well, the empirical formula actually is pretty easy. If you just remember, empirical formula, all I need is my moles for my known elements. So I could take the 2.172 grams of oxygen and divide by the 16 grams per mole that we know oxygen to have. And I get 0.1358 moles of oxygen. And if I do the same thing with sulfur, 1.448 grams of sulfur, and 1 mole of sulfur weighs 3207. So 1.448 divided by the 3207 is 0.04515 moles of sulfur. So now I can figure out my empirical formula, because SO, if I divide each of these by the smaller, 0.515, 0.4515, I'm going to get S1, and O, it appears, is going to be about 3.1358 divided by the 0.04515, 3.007. So yeah, my empirical formula is just SO3. The molecular formula is where this gets a little messier, and now we see why we need all this information, because I need to calculate the molar mass, or capital M. So now I'm going to use PV equals little m RT over big M, and I'm going to solve for capital M, or molar mass. So R, which R value do I want to use? Well, if I use it for kilopascals, remember kilopascals is in liters, so I should change this to decimeters cubed, or 1.120 decimeters cubed. And now I could go ahead and set up. So I'm going to pause and plug my numbers in down below. Well, you try and set it up yourself. And you may want to do like I did and rearrange, put M by itself, so then when you plug in, you're going to have. So there's my setup, and when I plug in, I get a molar mass of 80.89, or that'd be grams per mole. So now I can go ahead and figure out SO3 should weigh 3207 plus the 3 oxygen is 48. And if I add this up, that's going to be very close to the same mass there. So apparently the empirical formula and the molecular formula are the same. Number 60 is talking about a bicyclist who pumps up his tires very hard, so very hard would mean high pressure, before a trip over a high mountain pass. So the idea here is that you're pressured behind the tire, your volume is fairly low because the tire is kind of small, and near the summit one of his tires explodes. Explain why this might occur. Well, the reason it's exploding is because the volume, the pressure that the volume is, or the volume that the pressure is trying to occupy can't hold it. So what's changed here? Well, the number of particles inside remains constant, but what happens as you go up is the outside pressure pushing down on that tire. So now you've got a tire full of air particles surrounded by the inner tube, and they're pushing out. The pressure pushing in is not as great, which means the tire is going to be able to start expanding, which is part of your problem. And then on top of that, as you bike, your tires have friction with the road, which increases heat. So not only is the volume increasing, but you're going to see an increase in temperature. And with those two factors, eventually you're going to exceed the capacity of that tire. It is going to expand beyond what the tire is able to hold.